Good evening, Mahaganadhipataye Namah. Good evening to all. Good evening, children. Sahishnua. Who is Sahishnu? Okay. Good evening. Hi, Rehan. Sahishnu Rehan. Right, children. For essay 1, we have 8 topics in the syllabus. I already told you in the morning. Am I audible? Good evening, good evening. So, number system or number system, polynomials, fine. Number system, polynomials, pair of linear equation in two variables, quadratic equation, arithmetic progression, coordinate geometry, statistics and probability. So these are the topics we have. Yes. After some time it will be okay, right? After some time it will be okay. So I'm starting revision. So from which topic we'll start the revision, Nana? Which topic will go ahead with the revision? Good evening. Select a topic. Number system. Vanshika says number system. Okay. So number system, we have first fundamental theorem of arithmetics. Second one, LCM, HCF, and the relation between LCM and HCF. Fifth one, real life problems on LCM and HCF. Sixth one, irrationality proof. Irrationality proof. Okay, na? So this is So these are the 6 main concepts that we have in number system. First, try to recall this one, fundamental theorem of arithmetics. Okay. What fundamental theorem of arithmetic says? Suppose there is a composite number, for example, 112. There is a composite number. We can express this composite number into product of its prime factors. 2 5s are 10, 2 6s are 2 28s, 2 14s, 2 7s. So 112 we can express it as 2 power 4 into 7. We can write 112 has 2 power 4 into 7. Okay. And this is the unique. Unique means we can express any composite number into product of its prime factors in one and only one way. In one and only one way. There is no other prime factorization for it. So that is what fundamental theorem of arithmetic says. Every composite number can be expressed as product of its prime factors in one and only one way. Okay, na? In one and only one way. But see, the same 112, if I start with 7, 7 ones are 7, 7 6s are 2 8s, 2 4s, 2 2s, 2 1s, 7 into 2 power 4. Observe this one and this one. Observe this one and this one. Both are same. Here it is 2 power 4 into 7 and here it is 7 into 2 power 4. Order of the primes are changing, but the prime factorization is not changing. Both are same. Here we got 2 power 4 into 7 and here we got 7 into 2 power 4. Order of the primes are changed, but the prime factorization is not changing. It is only one way. So that is what the fundamental theorem of arithmetic says. Okay, na? Once again, I will try to say the definition. Fundamental theorem of arithmetic is every composite number can be expressed as product of prime factors in one and only one way. In one and only one way, except the order of the primes may differ. Except the order of the primes may differ. So I think you understood that one. Here we got 2 power 4 into 7 and here we got 7 into 2 power 4. So that is about fundamental theorem of arithmetics. Next one, LCM of two numbers. LCM of two numbers means, suppose there are two numbers 24 and 50. There are two composite numbers 24 and 50. Okay. Now, write down the multiples of 24. We will take small numbers. So let it be 12 and 15. Let it be 12 and 15. What are the multiples of 12? 12, 24, 36, 48, 60, 72, 84, 96, 108, 120, so on. Now, 15 multiples. 15, 30, 45, 60, 75, 90, 105, 120, so on. Okay, now you write down common multiples of these two numbers. Write down the common multiples of these two numbers. One is 60, the other one is 120. So 60, 120, 180, 240, so on. These are common multiples. These are common multiples of 12 and 15. In that, 60 is called LCM. 60 is called LCM of 12 and 15. Why 60 is called LCM? Because it is the least number in the common multiples of 12 and 15. 60 is the least number. 60 is the least number in common multiples of 12 and 15. All these are 60, 120, 180, 240, so on. All these are called common multiples of 12 and 15. In that 60 is the least one. 60 is the least one. So that's why it is called least common multiple of 12 and 15. Is that understood, children? Now, what is HCF? What is HCF? We will see that. Now write down the factors of 12. Write down the factors of 12. 1, 2, 3, 4, 6, 12. Am I audible now? Am I audible, children? Hello? Am I audible now? Okay. Now I think you understood HCF. You know that? Understand HCF? Okay. Now, this is over, this is over. Now see this one. If there are two numbers, for example 24 and 50, okay, take 24 as A and 50 as B. Now find out their LCM and find out the HCF, children. Find out the LCM of 24 and HCF of 24. Yes, children. What is LCM? LCM 600, HCF is 2, HCF 2. Now multiply both the numbers. Multiply both the numbers. Multiply 24 into 50. (24) with 50, multiply it. $1,200. Very good. Now multiply their LCM with HCF. Multiply the LCM and HCF of those two numbers. LCM and HCF now, that is 600 into 2, which is also 1200. Which is also 1200. So with this, what we can conclude? Product of two numbers is equal to the product of their LCM and HCF. Okay, na? Product of two numbers is equal to product of their LCM and HCF. Okay. Now, real life problems on LCM and HCF. Real life problems on LCM and HCF. Yeah, see this. In a seminar, the number of participants in Hindi, English and mathematics are 60, 84, 108. 60, 84, 108. There is a seminar in 3 subjects. Hindi, English and mathematics. Okay. Number of participants in Hindi is 60, English 84, mathematics 108. Number of participants. Okay, na? Find the minimum number of rooms. Find the minimum number of rooms required if in each room same number of participants to be seated and all of them being in the same subject. See, we need to allot the rooms. We need to allot the rooms for all these participants, but there is a condition that in each room, same number of participants must be there. That is first condition. And second condition is, and they belong to same subject. They belong to same subject. Is that understood? Suppose, for example, if first room is allotted, means if the rooms are allotted for six people, for example, 6 people. Each and every room 6 people are there. Means all the 6 people belong to same subject. They must belong to the same subject. Okay, na? Number of participants in each room is same and their subject is also same. That is what he is asking. Now what to do? See. Here in each room maximum how many students will be allotted, or you can see this maximum per each subject in each room, how many students will be allotted. That is what we have to find out. If we get maximum that word, we need to find out HCF. So calculate the HCF of all the three numbers. HCF of all the three numbers. 60 multiples 1, 2, 3, 4, 5, 6, 12, 15, 20, 30, 60. And 84 multiples 1, 2, 3, 4, 6, 12, 24, not 24, 42, 84, and 108, 108, 1, 2, 3, 4, 6, 12, 27, 27, 27 fours are how much? 108 only. 27, 54, 108. Okay. Or you can go ahead with the prime factorization. You can go ahead with prime factorization, that is easy. What is the prime factorization of 60? 2 square into 3 into 5. 84. 84 prime factorization. 2 square into 3 into 7. And 108 prime factorization. 54, 27. So 2 square into 3 cube. 2 square into 3 cube. Now what is HCF? What is HCF? Common factors with least power. Common factors with least power. 2 square into 3. So 12 is HCF. So 12 students will be arranged in each room. Each room we can allot 12 students. Okay. Now Hindi. For Hindi Hindi subject, total 60 students are there, so they will get 5 rooms. They will get 5 rooms. Meanwhile, 12, 60 by 5, 60 by 12, 5 rooms. Now, English, 84 students are there, 84 by 12, 7 rooms. English subject will get 7 rooms. Hindi subject will get 5 rooms. And mathematics, 108 by 12, 9 rooms. So, Hindi subject 5 rooms, English subject 7 rooms, mathematics 9 rooms. And each and every room will contain same subject only. The students in each and every room belongs to the same subject. So total number of rooms required is 21. So for conducting the seminar, total number of rooms are required is 21. Is that understood? So this is a real life example for LCM and HCF. Okay, na? Next one. One more example we'll see. See. Three pieces of timber Yeah, this will be understand to you easily. See this one. Six bells commence tolling together and toll at intervals of 2, 4, 6, 8, 10, 12 minutes respectively. 2, 4, 6, 8, 10 and 12. Okay now. In 30 hours, how many times do they toll together? In 13 hours, how many times do they toll together? First bell, it will ring every 2 minutes, after every 2 minutes. Second bell, after every 4 minutes. Third bell, after every 6 minutes. Fourth bell, after every 8 minutes. Fifth, after every 10 minutes. And sixth one, after every 12 minutes. Okay, now? First find out in how many minutes, after how many minutes, all the six bells will toll together. First you find out that one, children. After how many minutes, all the six bells toll together. So we need to find out there. What we have to find out? LCM. We need to find out the LCM. Find out fast. What is the LCM of all these? 1, 2, 3, 4, 5, 6. Again with 2. 1, 1, 3, 2, 5, 3. 3 to 1, 1, 1, 2, 5, 1. 1, 1, 1, 1, 5, 1. 1, 1, 1, 1, 1, 1. So LCM will be 2 2s are 4, 4 2s are 6, 6 15s are 90. How much है? One, 2, 3, 4, 5, 6. Again 2. 1, 1, 3, 2, 5, 3. Now with 3. 1, 1, 1, 2, 5, 3. 1, 2 to 5 to 5 2s are 10, 30, 60, 120. So LCM is 120. So all the bells ring together after every 120 minutes. After every 120 minutes, they'll ring together. Okay, na? Now, 120 minutes means 2 hours. So after every 2 hours, they'll toll together. All the 6 bells toll together. Now, in 30 hours, how many times they will toll together? In 30 hours, how many times They'll total together. 30 hours. So 30 by 2, 15 plus 1. So 16 times. 16 times they'll total together. Not 15 times, 16 times. Thirty by 2 plus 1. 16 times. Vaishnavi, you think and tell me tomorrow morning why it is 16, why can't 15? Try to understand and tell me tomorrow in the class. Vaishnavi. That's what. Whomever asking, think. Every 2 hours. Means 13 intervals there. 30 by 2, 15 intervals will be there. Two, 4, 6, 8, like that. See, total in 30 hours, how many times all the 6 bells will toll together? Okay, na? 30 hours means 30 by 2, 15 intervals will be there. So 15 intervals means 16 times. See, there is a problem, ladder problem in arithmetic progression, na? Even there also, this gap, how many gaps will be there? Suppose there are 1, 2, 3, 4, 5 gaps are there, then how many horizontal runs will be there in 5 gaps? 5 gaps, horizontal runs will be 1, 2, 3, 4, 5, 6, na? Yes. So here 15 gaps will be there, so total 16 times they will total together. 30 by 2, 15 gaps will be there, na? So that plus 1, 16 times they will total together. Okay, na? Okay, we'll see some more problems tomorrow on this. Real life problems on LCM and HCF. So that's all for today. Click on the like button and leave the class. So revision will be there every day in online class, and offline in the school I will continue with the syllabus. Click on the like button and leave the class, children.